Okay, welcome back to IGB100. This is week 9, and this week we will be introducing you to a new game base, that being the base for the Sidescroller. Now this is the third and final game that we are making in IGB100. Generally speaking, we're going to try to recycle as much content as possible from the previous two games, so if there's anything that's vaguely resembling something that we've made before, we've already made it. It's there for you to use straight out of the box. Now, having said that, there's going to be a lot of work regarding player animations, hitboxes, and controls. So generally speaking, this will be slightly more advanced than the previous games combined. So opening up this package on the main menu, this will be very similar to what you saw in the previous game. Feel free to change it, because it's pretty bland looking at the moment. But if you just navigate to the Sidescroller scene, we'll see exactly what this game is going to actually look like. Now this is technically functional now, but we do not have player controls. We're going to set that up, but before we do that, we're actually going to look into player animations. And this is going to be using Unity's new Mecanim Animations system. So to start manipulating this straight away, I first want you to add a new component, miscellaneous animator, to your player. Now here there'll be the option to add a controller. Most models that you'll import will have some kind of default controller set up for them. Having said that, it is pretty easy to make one yourself. So just select the Night controller and then go to Window, Animator. Not Animation, but Animator. And you should get a screen that looks something a little bit like this. So to start us off here, we're going to actually make something that kind of resembles a finite state machine in AI, but within animations. So we're going to allow a system to transition between animations logically. So certain animations will default to a certain animation instead if they're no longer being called. So the first animation we're going to make for this player is going to be an idle animation. So if you just right click here and go to create new state, empty, you'll be able to make a new state which by default is going to be connected to the entry state. We want to call this new state something that we'll recognize within our scripting. I'm going to call this idle, and it'll allow us to attach some kind of motion. In this case, we want one of the weight animations. So if you look carefully down the bottom here, you'll notice this one says the motion slime animation, the weight. We don't want this one, we want the one for the night. So make sure you select the right weight animation for this object. Cool. Now we're going to set up another animation. That is going to be the animation that gets played when we walk. So we're also going to rename this to something like walk. And this animation is going to grab the walk animation. Again, making sure you pick the one for the night. Now, by default, this walk animation isn't called. We're going to be calling it through script, but we want the walk animation to then run some other animation if it's no longer being used. So what we need to do here is set up a transition between walk and idle. Now, if you are finding that when we actually do get to play these animations and they're maybe not smooth enough, you can actually adjust where specifically these animations overlap. But for the moment, we will just leave it as is. Now we're going to quickly set up just a couple more additional animations. The first one is going to be one that I'm going to call attack. And this is going to use the attack animation with a default transition back to idle if it's no longer being cast, as well as another animation that I'm just going to call hurt, as in an animation that's going to get played when I take damage. Transition back, and this will use the damage animation. Again, making sure you pick the correct one. Finally, we're going to have one more animation that is actually not connected to anything. If anything, it would be connected to your exit state, but we actually don't need to hook that up. This one is going to be the state that is called when we die. Now, that one didn't seem to save for some reason. I'll just go and rename that. Hurt damage. So this will be the state that is set when we are dead, and this will simply play the death animation for the night. Cool. Now, one final thing that you may want to tweak here is that these animation speeds are a little bit wonky. Specifically for the walk animation, it's a little bit slow. I'm going to speed this up because I know beforehand that it looks a little bit too slow for my liking. And I'm going to slow down the speed of the death animation. But again, you can change these settings to be whatever you want when you actually see these animations in practice. Now, there's a lot of things that you can do with the Mecanim system, but this will suffice for the level of detail that we want in our game. Feel free to explore the Mecanim animation system much more extensively. There are some pretty interesting things you can do, particularly with transitions and linking transitions back to other states, kind of the things that you can do, say for example having multiple idle animations. It's quite interesting. So now that we've set up some basic animations for our character, I'll just get you to put this window away for the time being, so it's readily available in case we do need to make any changes. But before we jump into actually scripting this, I want you to do one additional adjustment, and that's going to be to the knight's attack animation. Now we can preview this right now by clicking on that attack animation and dragging in a model for it, because this particular animation is not directly connected to the model. So let's drag the player into that, and if you press play now, you'll see in the bottom right that the knight is actually playing that attack animation. That's looking pretty good, but you'll notice if I just drag it to about this point, it's about that point where you want that animation to actually do damage. Now this is an interesting topic because a lot of games, in fact a large number of games, only do damage at specific points during the animation. In fact, a really good example of this is your typical fighting game. For any of you that know anything about fighting games, you'll know that there are frames of animation that get cast before an active hitbox is allowed to do damage to the enemy in question. And we're going to set up something similar to that. We want specifically at this point, roughly at about this point in our animation, an event to be made, where in this case we're simply just going to spawn a hitbox where we do damage. Now this can be achieved very easily just by selecting the animation in question and expanding the events section so that you can see specifically which frame of animation you're up to. In this case I want something roughly about there, and making a new event or adding one. Now by default that's called new event. I'm actually just going to call this event something straightforward like damage. We do have the option for parameters, but I'm just going to leave it and press apply. Now what this is going to do is create an animation event called damage, that any script that we have attached to this object is simply going to be called, and whatever is within that method is going to happen. So we could have particle effects associated with that, we could have additional animations. In this case I'm just going to spawn a hitbox, but we'll get to that section in a little bit of time. So in order to cast this damage event, but additionally also to make use of our animations, we are going to need to script them. It's unavoidable. We do need to call animations through scripting most of the time. So with your player selected, open up the player script. As you can see, a lot of this script is already done for you, but we are going to be adding quite a significant chunk in addition. The first of which is going to be a reference to our animator component on the object that we're just going to call animator. Now, our object in question also uses a rigid body, so we are going to need to gain reference to this rigid body as well, and I'm just going to call it RB, something simple. Our player is also going to be moving around, so there are going to be some very simple walking variables, the first of which will be a private float related to move speed, and I might make that something quite small like 2, as well as the fact that our player is going to be facing in 1 or 2 directions, so we're going to need some kind of container holding the rotation information of our player character. In this case, I want you to make what's called a quaternion, and let's call it new rotation, and that doesn't need to be filled with anything. That might seem a little bit confusing at this point. I will get to that point in the code and explain it a little bit better. In addition to this, our player is also going to be jumping around, so we'll need some jumping variables. The first of which will be, let's make a public float jump force, something that we can adjust later if we don't like it. By default, I'll make it something large, like 200. We also are going to make use of a float that is essentially the distance to the ground. And this is going to be used for what's called a ground check. We're going to raycast directly downwards and see if we're close to the ground, and if we are, set a flag to be grounded equals true. So let's make a private float. We'll call it dist to ground, and we'll just make it 1. Finally, we want to cool down on our jumping, so let's make a private float jump cooldown. We'll make it something like 0.5, so every 0.5 seconds you can jump, so you can't spam it constantly and go flying off into the sky. And we'll have some kind of timer controlling that, so another private floats jump time. Now, some of these variables we need to initialize in start, so we'll go down and initialize those straight away as quickly as we can. First of which is the animator component, and this needs to be equal to a get component call animator. Secondly, our rigid body also needs the same setup. So I'm just going to copy this code and type in rigid body here. Our dist to ground code. Now, as I said before, this is the distance that we need to raycast from the center of our object straight down. And this is essentially going to be an interesting bit of code, which is our transform get component collider. So we're specifically talking about our collider's properties at this point. And we can here reference the bounds of our object, specifically its extents, and the only axis I care about is its y, i.e. straight down, the extent of its y axis. So that's our distance to ground. Finally, our new rotation is going to simply be equal to our transform.rotation. So the next part of this is actually programming the controls. And we can first of all set this up in update by talking about our player controls, but specifically if we are alive. Because if we're dead, we don't want control of our character anymore. We don't want to be jumping around like a corpse. As a corpse, I should say. So, what we really want to say here is that if we are not dead, which is a boolean we already had set up for you, then give us access to controls. And that's not that. This is a method that we need to write later. Else, if we are dead, then the animator component should play dead. And it's only going to play it once because the death animation doesn't link back to anything, nor is it looped. So when we die, we're going to lose access to our controls, it's going to play the death animation, and that is going to be it. That is all that's going to occur regarding the update. So to make use of this, let's go down to below update and make a private void controls method. So here is where things are going to get a little bit complicated. Because we're controlling a player character that's using a rigid body and also has a collider, we need to account for a lot of things. Things such as if we're grounded, if we're, the amount of force that we're being applied to in certain directions, and which direction we're facing. So there's going to be a bit of code that we need to account for here. So let's start at something a little bit more complicated, and that's going to be jumping. So if we're jumping, we're first of all going to need to check if we are inputting some kind of key in, and I reckon the best key for that is going to be spacebar, assuming you spell it correctly. So if we are pressing spacebar and we are on the ground, right, and it is the time greater than jump time, as in it's time to jump, our cooldown on our jump is ready to go, then let's do something about that. But before we can do that, we need to write this method, isGrounded. Now isGrounded is going to make use of this distance to ground variable that we allocated at start. And all isGrounded is going to be will be a private bool, so not a void function. We actually do want a return for this. isGrounded. It doesn't accept parameters, but it does return a variable to us which is in the form of a physics.raycast query. And this raycast is going to be from our transform.position, as in the center of our character. The direction being the negative vector3 dot up, so essentially down. So we could almost say vector3 dot down. And this distance is going to be by default the distance to ground, as in the variable we allocated before, plus just a little bit more. So I reckon 0.1f, just a little bit, tiny bit more distance to check to see if we are close to, if not flush with the ground. And if we are, this returns true, which is great. So if that's all true, we can then say that we want to go up, which means we need to talk to our rigid body. And here we specifically want to add force. We don't want to just say move up slightly, because when you're dealing with a rigid body, we're dealing with aspects like gravity. We want to make use of the physics engine to tell it to go up a little tiny bit and let gravity pull you down. So here we want to add force. The direction of that force is going to be along a new vector3 with specific variables on the x, y, and z axis as 0 on the x. Along the y, we want our jump force, and on the z, we don't care about it, so also 0. And the type of force that we're going to need here is force mode dot force. So just straightforward force application. That needs to be a capital F. So that's going to make us go up. It's going to make us go up for one instance of this spacebar holding down, which is great. We can also add a noise to this, and this is a noise that we had previously set up for you. I think we called it jump sound, and that's just going to be from our transform.position, if you can spell it correctly, and your transform.rotation. Finally, we want to make that jump time go up slightly, so we'll simply make it the time.time and equal to our jump cooldown, which I think we set to 0.5 seconds. So to test that now, just go back into Unity, make sure you're not getting any red errors in the console. These ones should be fine. Press play, and just press spacebar and see what happens. That is looking about right. So the next thing we're going to do is add an attack. And this is actually where we're going to start making use of our animation system. You may have noticed that you were actually already idling just before, but there is no jump animation for this, unfortunately. So let's get the attack animation working correctly with an attack. Here we want to input dot get key down, some kind of attack key. I'm just going to make mine F. And we also want to check if it is time to attack. So time.time greater than attack timer, I think we may have set up for you. Yeah. So first of all, let's just go animator dot play attack. So that'll be specifically what you called it within the Mecanim system. So if you did call yours something different for whatever reason, it'll need to be that. Now if you remember correctly, we in our attack animation set up an event. So in terms of us writing code for doing damage in this section, we don't need to. We need to do that in a separate section that's called damage, that event function that gets called. So all we need to do here is similar to the jump, just instantiate maybe some kind of sound. I think we called the attack sound, funnily enough. And the jump, or attack time I should say, I don't think we called it attack time. We might have called it attack timer. And instead of jump cooldown, it's attack rate. So same deal as jumping, basically. But we need to write that function. That is, I believe, a public void damage function. So again, this is that event function that is hooked directly up to our attack animation. So it's within this part that we are going to spawn that damage hitbox. And to do that, we actually need to set up a couple of variables first relating to that damage hitbox. The first one is going to be a public game object damage location. Now that's where we're going to spawn the damage hitbox. The other one is going to be a public game object damage hitbox, which is going to be the hitbox in question. So, going back down to our damage method, we can now write an interesting bit of code which is very powerful in terms of manipulating objects when they spawn. We want to make a game object hitbox, and it's going to equal an instantiate call. We're going to spawn our damage hitbox. It's going to be from our our damage location transform position. And our damage location transform rotation. Now, when we start manipulating objects like this, we can start referencing them because we've declared this as a game object hitbox, something that is a variable that's accessible within this method call right now. So we can tell this hitbox to be something. Specifically, we can talk to components on that hitbox by saying hitbox.getComponent. In this case, that component is going to be a damage hitbox, which is a script that we've already made for you. It's an existing class, and that class has, as you would imagine, a damage variable on it. That's going to be equal to the damage that we're dealing with our sword. So we're going to swing a sword. Our sword's going to do whatever, 25 damage. If we were using a battle axe or something and we wanted that to be slightly more damage, we could tell the hitbox, this hitbox, to change its component right now to be something else. We can change that variable. So we could actually test this out right now. We may need to set up some object properties first though. Yes, the first of all is going to be a damage location. Now we've set up for you already the location where our hitbox is going to spawn. In this case, it's just going to be directly in front of the player. So, with the player selected, drag that damage location empty into that section. The damage hitbox is also something that we've set up for you. You'll find that in the prefabs folder. It's just a, well, it's not anything really, it's just a collider with a script on it that does the damage in question. If you would like to check that out, you may also do so. With the player selected, go to the prefabs folder and drag that damage hitbox into there as well. Cool. So if you press play now, assuming again you don't have red errors, make sure that's never the case, you should be able to press your attack button, and if you see here, besides the sound, our damage hitbox is appearing for a fraction of a second, and that's because the hitbox by default only lasts for 0.1 of a second. So just pausing it while we're playing the game, you can see that this damage hitbox has spawned, which means that any enemy that's in there that is tagged as enemy is actually going to take damage. That's the basic principle of using a hitbox system within these kind of games. So right now we can jump and we can attack, but we still can't move, and that's not going to be useful for us until we actually can. So let's address that. And this isn't as straightforward as you would think, primarily because we need to account for the fact that we need to swap our model's positioning around completely. So within controls, underneath attack, write a new section that's essentially walking. And here we want to check for inputs .get key. I'm going to bind my walking to the right key to be D. If that is happening, I want to call a method that's called walking. And I'm going to feed it a parameter called 1. And you'll see why I'm doing this in a second. We can't walk both left and right, so we might as well put this in an else if with the same deal. Else if I'm pressing A, then make walking -1. Now for some of you that may be thinking ahead a bit, this parameter that I'm feeding this method that we are still yet to write is the direction. We're either facing right, 1, or left, -1. And that's simply going to swap our transform around to be in a certain direction or 180 degrees opposite. So let's write that walking function. Walking is going to be a private void walking. And it's going to be specifically in a int direction. Walking is also going to check to see if we are grounded. Because if we are grounded, then we want our animator to play the walk animation, as you would expect. However, if we're not grounded, we maybe don't want to be walking in the air, so let's just default to playing the idle animation. Now, ideally you'd have some kind of jump animation or in the air animation you'd play here. We don't for this model, so it's okay. Now for the important part. We want to use that new rotation variable we set up before to tell its Euler angles, to be a new vector 3 that is the new rotation's Euler angles dot x on the x, but on the y we just want this to be direction, because the y determines whether or not we're facing left or right. We multiply this by 90, and for the z we just feed that exact thing in, but we put z there. So to explain this again, this moves us around. We are by default set to 90 degrees on the y. If we multiply 90 by 1, we're at 90. If we multiply it by -1, we're at -90. So essentially, we're flipping our model around 180 degrees. We then want to set our transform.rotation to be, as you would expect, new rotation. So update our transform. Be this new XYZ rotation. Finally, we do need to control how fast we move. So when we're using force, it's important that you have a cap on how much force you apply to certain things. We didn't need to do it for jumping, because when we jump, we can only jump every 0.5 seconds. So that by default is a cap. Now we don't want a timer on our walking system. We do want to walk every frame, but we do want to cap how fast we can go. So specifically, if our rigid body's velocity is maybe less than 35, then add force. And this is going to be in the form of a new vector 3 that is going to be in the direction that we are facing, either 1 or -1, multiplied by some value, let's say 500. And never forget to account for delta time. So regardless of how quickly our game is running, if we put delta time in this equation, it'll be normalized based on the performance of our machine. We do need to feed a couple more zeros to the end of this. And finally, the type of force that we are going to apply to this thing will be force mode dot force, so your standard force. And again, that needs to be a capital. I keep forgetting that. This needs to be dot x. So specifically when we're adding force to an axis, in this case, this being the x-axis, that's actually the axis that we're moving along with regards to our player model. We can't just add to its velocity, because that means the velocity in whatever direction it's moving. We just want to add it to x-axis velocity. Cool. So we can check that now. Go back into Unity, make sure you have no errors. I know this has been a very script intensive session this time. It is necessary for this game. If you press play now, you should be able to move left and right. That's looking about right. So that's it for this week. Next week we're going to start talking about putting an enemy into here. We do by default have an enemy zone set up for you, but it's not currently working 100%. We're going to fix that up, add a little bit of AI so that we have an enemy that can patrol and move around a bit. Otherwise, we'll leave that for next week.